So first, foremost, how do you pronounce the name?
Flexiv is our
Flexiv.
company name.
Okay.
And the Ryzen is
Yep.
the robot name.
Okay.
So
and this is a 7-axis cobot as opposed to a 6-axis cobot because.
yeah, actually we think our robot's like adaptive robot. It's cobot plus next generation of technologies. We do everything a cobot can do. The other things that cobot can't.
Right, and you said it's kind of more like natural, like the human arm, because it has 7 degrees of freedom versus the 6 degrees of freedom.
So we design our arm to be as close as possible to a human arm. So it has 7 axes, and it has force language. So while the other cobot they talk in position language, we talk in force language. That's how we do tasks can only be done by human arms.
Yep, and this has force feedback, and it's a what's the reach on it, and what's the payload?
So for this one, the payload is 4 kilograms.
Yep.
For the bigger one, the darker ones,
yep,
that is 10 kg.
Okay,
10
so
kg
you have 10 and 4.
We currently have 4 models.
Okay.
So namely Ryzen 4, Ryzen 10, and 4S and 10S. So the number means the payload, and the S after the number is if you have an extra force shock sensor here. So without this extra sensor, our robot is still able to sense the force and do all the force tests. The difference is that with this added force shock sensor and end effector, the resolution goes from goes from half Newton to 3 grams. So for application that requires very fine force sensing, we would recommend adding this sensor.
Right.
But for general force tasks like that, and the assembly, we would just go without.
Right, makes sense.
Right.
Now, in terms of control, you mentioned before, you can do everything with just the, what do you call that white bar there?
So we have a UI tablet, and in this UI tablet, you can drag and drop building blocks. These building blocks are wrapped up by us. It's like basic skills of the robot. You can drag and drop it and save and assign to the robot. And this is the motion bar.
Yep.
So this motion bar has a stop, which is safe, enabling button. This is for when you do free drive, you need to hold this.
So you can use that to put it in free drive, and then you can move it to where you want, get the positions you want, store them.
Like a cobot.
Right.
So to get into free drive, you press this button here, and it goes to the free drive. And if you, I can show. So if I just stop this, and I'm going to press this button, it goes to dark blue. And right now, it can't move yet.
Okay, not yet.
Because in this UI tablet, you
Yep.
need to select which of the directions we want to free drive.
Right. Do you want it to just go X, Y, or X, Y, Z?
Let's just unlock X and Y, and when I press this enabling button,
and I can move it back and forth, but not on the Z.
Is locked.
Right, and it's very smooth as I'm moving it around.
Yes.
Yeah, and can I twist the end?
The twist is locked right now.
Okay.
So I can let me quickly when I unrelease release it, it'll stop. So here, if I unlock the rotational directions, it is RX and RY. Say if you remove RX only, so let me press this, and you'll be able to rotate.
Yep.
Yeah.
Cool. And then in terms of the SDK, so you have an SDK. We saw it on your website.
Yes.
It's Python and a C++ SDK.
Yes, we provide the Python and C++ SDK for Mac OS, Linux, and Windows.
Okay.
And you can run both non-real-time and real-time access to the robot.
Okay.
Real-time means you can control the robot at 1K hertz, and you get all the real-time data from each of the joints, and also as the end effector, like position, velocity, torque, force, moment, everything you get.
And you get all that through an Ethernet connection to your computer, correct?
If you view the control box here, and
down here, Matt,
we have Ethernet ports. So this one goes to UI.
Yep.
The UI can also be connected via Wi-Fi. So we just make a wire connection for stability. And if you have a SDK computer, you just plug your SD computer in here.
Yep.
And you just run the program. The robot will follow you.
And there's also digital I/O on this, so you can control.
So we have 16 digital I/Os where you can also control via SDK. And we have safety I/Os. These are for safety functions like light curtain, reduced mode, sort of that, so things like that. Okay.
And when you buy it, it comes with you direct to customer, right?
Yes.
So no distributors.
Yes. We ship from California. We have more in Santa Clara, California, center of Silicon Valley, and we provide technical support.
Sweet. And it comes with the box, the tablet, and the robot.
Everything you need to run.
And you also had mentioned that you're working on potentially getting a software such that you could run the software that's running on the tablet on just your own computer.
Yes, we
Yep.
provide. We are planning to push out a software where you can install on a desktop. That software is more powerful than the one runs in the tablet because
Yep.
this tablet has limited computation power. So on the desktop, we will provide simulation.
Mhm.
Say you have composed the plane here, and you want to see how it runs on the robot,
Yep.
but you do not want to run the actual robot.
Mhm.
So we provide a preview functionality. That's basically a simulation functionality. You can just preview your project on
Yep.
in the simulation environment.
Cool.
And and we also provide software functionality like you provide a CAD model to the software, and the software can generate the trajectory automatically.
Yep.
And we also provide the software where you can mount a camera in here
Mhm.
and use the camera, do an auto scan of the object,
Yep.
and use the scan result to automatically generate trajectories.
Yeah. So like if you wanted to stand a part or something, you
Yes.
could auto scan the part.
Say a boat. You
Right.
have a boat.
Yeah.
Your boat has some part you need to on the coating you need to
Yep.
fix. You just let the robot scan the boat, and the boat has complex curvatures.
Yep.
So just scan the boat and do the automatic.
Yep.
chip
So you can
camera.
use any camera, plug it right into your software.
Yes. Mount it here.
Mount it there.
to the
That's
USB
awesome.
on the
Yep.
VirtualBox.
Awesome.
Yeah.
Sweet. Well, thank you very much for that.
Thank you. Thank
Yeah,
you, Jim.
absolutely.